Welcome to February 11th LeetCode Challenge, Permutations in String. Given two strings, S1 and S2, return true if S2 contains a permutation of S1, or false otherwise. In other words, return true if S1's permutation is a substring of S2. So that means that, let's look at example number 1 to kind of clarify what the question is asking. So you have input S1 being AB, and then you have S2 being this string right here. So essentially, is S1 a permutation of the substring S2? The answer is yes, because we have A and B located within string 2, and they don't have to be in the same order. Alright, it's a permutation, so any combination of it will do. However, actually, no, it has to be a substring, so A and B have to be connected together. So let's see, is AB a substring of this following string 2? The answer is false because both A and B are separated by an O, so they're not a substring. Substring means they need to be connected. Alright, so we have a length of S1 and S2 is between 1 to 10 to the 4. S1 and S2 consists of English lowercase letters. So there's there's a lot of hints here. Probably not going to look at them because I'm thinking of using a sliding window type of approach with sorting of strings. So the first thing you want to do is define, so if this is the case, if you want to know if S1's permutation of substring of S2, then let's rule out the cases where S1 is larger, the size of S1 is larger than the size of S2. So if the length of S1 is greater than the length of S2, return false, because we can never make a substring from S1. We can never make a substring of S2 if S1 is larger. Return false. Next, we are going to let's see, convert all of the string S1 into a single. We're going to sort it actually. So we're going to take S1 and sort it alphabetically. So to do that, we are going to take an empty string. We're going to join dot sorted I should say, S1. So we're going to convert the string S1 into a sorted array, a sorted string alphabetically. Then we're going to use our sliding window approach where we're going to keep an index, so index equals 0. So while index is less or equal to the length of the substring of 2 minus the length of S1, because we need to know whether we're going to make a substring of it or not. Whether that's the case, well, that's true. What we want to do is do a couple of things. The first thing is we want to define a current substring. So if we go along, if we can make a current substring, then we want to return true. Otherwise, return false. So when it exits the while loop, then it returns false. If not, then it stays true. And how do we know it's true? It has to be the current substring. So I'll call it current. And that's going to be a similar idea. We're going to join them together alphabetically and compare them together, ideally. Compare the string current to the S1 joined. So how do we do that? We make an empty string again. We're going to join together. And then we're also going to sort it as well. Sorted. So what specifically are we sorting? We're sorting string 2. And how we're going to sort that? We're going to sort it by the index of the slicing between I to I plus 1 plus the length of substring 1. So ideally that we're taking the slice of the substring 2 from the index I to I plus the length of S, so that we contain anything inside. So if we can make this, then that means it is a substring of S2 However, we need to make sure that it is the substring exists in it's equal to S1 ideally. So if current is equal to S1, remember they're both sorted and joined together, then return true. Else we gotta increment our I to the next number. The good thing about being a substring is that it has to be contiguous, so that any space or break within the substring will not work. So therefore, if we take A, B, A, if we sort it to A, B, we'll get it equal to current to S1, return true, then move on to the next index if it's not true. If we finish this while loop, and if we never return true, then obviously we gotta return false. Okay, let's submit this and see how it goes. Let's see. Looks good. So time complexity would be big O of n log n. We do have this while loop here, but the sorted. Oh, this is okay. Good. So this is taking a bit long time. It's actually the memory actually kind of sucks. It's big O of n log n because of the sorting algorithm. Actually, it's big O n squared log n because we have this while loop which is iterating through the length of each index in the string, which is n max n. But we also have within the while loop we have the sorted algorithm and join algorithm as well, which also has its own time complexity. So it'd be big O n squared log n, I believe. Memory complexity, which is memory space, we just basically return a boolean and we store everything inside two strings here, which is n, which is pretty good. Can we make this a little better? So this is using a sorted string sort and sliding window approach. Can we make this a little better using hash maps? Probably. Do I want to? Yeah, sure, why not? Let's try it out. Instead of using sorted algorithm, I'm going to use a hash map, and the hash map is going to be a counter. Let's do it. So let's call it counter1, and we're going to use a counter, let's call a counter Python function. So S1, we'll still keep our index the same, keep everything else the same. For this one, I'm going to call it counter2, and that's going to be the counter of let's see, S1 index, S1, yeah. Now we need to make sure those two are equal, so it'll be current2 is equal to current1, return true index, return false, and let's see. And we have to import counter collections here. No, we don't. Let's submit that. So basically this is the same approach, but using, instead of sorted, we're going to use a counter or hash map, which does slightly better because of the reducing the sorting complexity, but we still have this big O and while loop. Alright, that's it guys. Have a great day guys.